I tried to explain one of the questions of the homework using this example here. X to the third power minus 3x squared plus x minus 3. So first thing we need to do is Descartes' Rule of Signs. So looking at this, I see that there is 1, 2, 3 sign changes. So that means if I'm making my table, I could have 3 or 1 positive real roots. If I substitute in negative x, let's do f of negative x. F of negative x okay, so this is going to stay as negative x, which means it has changed from our original one. This is not going to change because it's a positive number, it's a negative number being squared, and this is going to change, and that's going to stay the same. So now I have all the same signs, which means that there are no sign changes. That means that there are going to be no negative roots. Okay. Since our degree is 3, that means that if we have 3 positive real roots, we will have 0 imaginary roots. But if we have 1 positive real root, that means there's still 2 roots that could exist, and they're going to be imaginary in that case. Okay, so that's Descartes' Rule of Signs. So now let's look at the rational root theorem to figure out what our possible rational roots are. To do that, I look at the leading coefficient, which in this case is 1, and I look at the constant, which in this case is negative 3. So the negative doesn't really matter right now, so let's look at all of the factors of 3, or I guess I'll stick with negative 3. So it could be plus or minus 1, or it could be plus or minus 3. And the leading coefficient is pretty straightforward, just 1. That means our possible rational roots could be either positive or negative 1 over 1, which is 1, or positive or negative 3 over 1, which is positive or negative 3. So I know that there are 0 negative roots, so I'm not even going to test these negative roots. So let's start with 1. So let's see what happens when I do f of 1. So I'm doing the remainder theorem, just plugging in a number and seeing if I get 0 as my remainder. So I'm choosing these 2 things to plug in. Remember I said I'm not going to look at the negative ones. So if I get 0 as a remainder, that means that this x equals 1 is going to be a remainder. So I have 1 to the third power minus 3 times 1 squared plus 1 minus 3. Okay, this will be 1 minus 3, because 1 squared is 1, times 3 is 3, plus 1 minus 3. Negative 2, negative 1, negative 4. So since that does not equal 0, it is not a 0 or factor. That's what rational root theorem, that's how rational root theorem will help us in combination with remainder theorem. Okay, let's try another one. Let's try our other positive root, 3. So we're going to do f of 3. So I've got 3 to the third power minus 3 times 3 squared plus, 3 minus 3. So 3 to the third is 27. 3 squared is 9 times 3, that's going to be minus 27, plus 3 minus 3. 27 minus 27 is 0, plus 3 is 3, minus 3 is 0. That means that we found that x equals 3. We found that x equals 3 is a 0. Okay, woo! So let's do some synthetic division now to figure out the other factors. So I've got my synthetic division set up. My leading coefficient is 1. After that is negative 3 for my x squared term, then 1 for my linear term or my x term, and negative 3. Okay, bring down the first term. 3 times 1 is 3. Negative 3 plus 3 is 0. And then 3 times 0 is 0. Add down again, we get 1. 3 times 3 is 3. And when we add down, we get 0. So perfect. I got a remainder of 0. Remember that this is my constant term. Then this will be my linear and quadratic. So that means that my quotient will be x squared plus 0x plus 1 equals 0. So looking at this, I have found one positive real root, and it's looking like I'm going to have two imaginary, so it looks like I'm about to fall into this case. So I'm going to just use inverse operations. So we'll subtract 1, x squared equals negative 1. Here, let me come over here. X squared equals negative 1. I just subtracted 1 on both sides. Now I'll take the square root of both sides. So I get x equals plus or minus square root of negative 1. And that, of course, is I. So I get x equals plus or minus I. So I got this as these as 2 zeros, and then I had found this before, which means my 3 zeros are right here. And that's all that your homework is asking you. Great.